Welcome to this video on mains electricity. We will cover the basics of alternating current, how electricity is supplied to our homes, and the components of a standard plug. The key areas we will cover include understanding and identifying electrical hazards like frayed cables and damaged plugs. We will also examine the uses of safety features such as insulation, earthing, fuses, and circuit breakers. Direct current, or DC, is supplied by cells and batteries and always flows in the same direction, as shown in this circuit diagram. Alternating current, AC, constantly changes direction. The lamps work with both AC and DC sources. Mains electricity supply to UK homes is an alternating current supply. The current changes direction every 1/100th of a second, completing a full cycle every 1/50th of a second. This gives it a frequency of 50 Hz. The UK mains supply is rated at about 230 volts. One side, the live terminal, constantly changes between plus 325 volts and minus 325 volts. The other, the neutral terminal, remains at about 0 volts. Touching the live terminal can be fatal. The voltage of the live terminal varies sinusoidally between plus 325 volts and minus 325 volts, taking 0.02 seconds to complete one full cycle. Let's test your understanding with this fill-in-the-gaps activity. Try to select the appropriate words from the list to complete the sentences. Here are the answers to the fill-in-the-gaps. Direct current flows in one direction and is supplied by cells and batteries. Alternating current constantly reverses direction. Main supply is AC, supplied at 230 volts and 50 Hz. An oscilloscope can display and measure a DC or AC waveform. An electrical cable consists of a live wire with brown insulation, a neutral wire with blue insulation, and, in many cases, an earth wire with yellow and green striped insulation. These wires are housed inside an outer layer of rubber or flexible plastic. The earth wire is a crucial safety feature connected to the device's metal casing and runs into the ground. Appliances with plastic cases, like hair dryers, do not require an earth connection. This diagram shows the inside of a standard 3-pin plug, identifying the live, neutral, and earth wires, the fuse, and the cable grip. Common materials used in plugs, sockets, and wires include brass for plug pins and socket terminals, copper for wires, plastic for the plug and socket casing, and rubber for wire insulation. Take a moment to label the numbered components in this plug diagram. The components are 1. Earth wire, 2. Neutral wire, 3. Cable grip, 4. Live wire, and 5. Fuse. This concludes the video on mains electricity. Let's review the components of a standard 3-pin plug. Identify the earth, neutral, cable grip, fuse, and live connections shown in the diagram. The correct labels are: 1 is earth, 2 is neutral, 3 is the cable grip, 4 is the fuse, and 5 is the live connection. The cable grip is critical for holding the cable firmly in place. Now, observe this incorrectly wired plug. Identify the main faults. The earth wire is unconnected. Some bare wire strands are showing, and the live and neutral wires are swapped. Additionally, the cable grip is not properly gripping the outer plastic insulator. Note that while the appliance might still function, this wiring is extremely dangerous. Let's reinforce your knowledge with another fill-in-the-gaps activity, using the word bank provided to complete the statements. Here are the completed sentences. Electrical cables contain 3 insulated wires. 2 core cables are used with appliances with plastic casings. The live wire has brown insulation, the neutral has blue, and the earth has striped yellow-green. In a 3-pin plug, the live is connected on the right next to the fuse. The neutral is on the left, and the earth is connected at the top. The 2 main dangers of mains electricity are fire and electrocution. Fire can be caused by excessive current. Fuses and circuit breakers limit current flow. Electrocution can occur from contact with the live wire. A current of over 100 milliamps can be fatal. The earth wire, fuse, or circuit breaker can prevent electrocution. A fuse is a wire designed to melt and break a circuit if the current exceeds a safe limit. Examples include fuse wires, cartridges, and standard 3A, 5A, and 13A plug fuses. The thicker the fuse wire, the greater the current needed to make it fuse. Fuses are supplied with a limited number of current ratings, and the modern symbol for a fuse is shown. A circuit breaker is an electromagnetic device that rapidly breaks a circuit when the current is too high. This includes RCD circuit breakers for appliances and those found in consumer units. In a simple circuit breaker, current flows through the electromagnet. When the current increases, the electromagnet pulls the armature and a spring separates the contact, stopping the current. The reset button can reconnect the circuit after it breaks. Both fuses and circuit breakers prevent fire. Fuses are simple and cheap, while circuit breakers are faster and resettable. Appliances with metal cases are earthed by connecting the earth wire to the case. The metal case is normally at 0 volts. Current flows between the live and neutral wires through the appliance's heater. Let's test your knowledge of mains electricity dangers and safety features with this fill-in-the-gaps exercise. Choose the best words from the selection to complete the sentences. Here are the completed sentences. The two dangers are fire and electrocution. Fires are caused by too large a current. A fuse or circuit breaker in the live wire limits the current. The earth wire prevents the metal casing from becoming live. A large current flowing down the earth wire will cause the fuse or circuit breaker to isolate the live connection. The correct fuse is the next size up from the calculated current. This ensures the appliance is protected and the fuse does not blow under normal use.